Hi everyone, we're going to evaluate the definite integral over the interval 0 to 0.6 of this function. So basically what we're using is our table of trigonometric substitutions, and this one has the form of here. It's a little different. It's not our usual form because we have this 25. So if you do this temporary substitution, because we know that 25x squared is 5x squared, we'll just let u equal 5x, and therefore x equals u over 5. And once you do some of these, it makes it easier. So basically our a is going to be 3. And this should be a negative there. So basically what we're going to do for our substitution is let x equal 3/5, because our a is 3. And I'm going to substitute that in for the u. So 3/5 sine of theta. And you'll see why this works. And after you do these kind a lot, it becomes clearer. So our derivative of x is just going to be 3/5 cosine x, or cosine theta d theta. Now when I plug it in, let's look at this. We're just gonna look at that. So we'd have 9 minus 25 times 3/5 squared, or sine, the squared, sine squared theta. So what happens is you get 9 minus the 5 is going to cancel, because 5 squared is just 25, and you get 9. So that's why we set it up the way we did, because now we can just write this as 9, 1 minus sine squared, and then factor out the 9, or pull out the 9. Square root of 9 is 3. 1 minus sine squared is cosine squared. And then since we're in quadrant 1 to 4, or 4 to 1, we can just write this as 3 cosine of theta. So that's what this equals here. So now, let's go ahead and do our substitution. So we're going to have, this is going to equal, since we did our substitution, we need to change this as well. Our integrals, our bounds. So when x is 0, my angle is going to be 0, because we have to be between in here. So that's still going to be 0. All right, when x is 0.6, remember this is 6/10, which reduces to 3/5. So we have 3/5 equals 3/5 sine, and this has to be pi divided by 2, because we want this to be 1. We want 3/5 to equal 3/5. So this is going to change to pi divided by 4. And now let's substitute in, and we're going to get our x. So this is our x. So that's going to be 3/5 squared sine squared theta divided by this portion, which we already know to be 3 cosine of theta, and then times d theta, which was, or dx, which is this piece. That's going to be 3/5 cosine theta d theta. So this is what we have so far. All right. So I'm going to clean this up on the next section. So the first thing I'm going to do is, this is going to be 9/25 times 3/5, and divided by 3 is the same as multiplying by 1/3. And I'm going to pull it out. So when you do that, you're going to get 9 divided by 125 from 0 to pi divided by 2. And then we had, when you clean up the cosines that we had before, sine squared theta divided by cosine theta times cosine theta d theta. So these cross out, and so you're just left with sine squared theta d theta. All right, so now what I want to do, since I have this, is use my half angle. So I have 9 divided by 125 from 0 to pi over 2. And I'm going to use my half angle formula, which is 1/2 times 1 minus cosine 2 theta d theta. All right, now let's integrate. When you integrate, you're going to get 9 divided by, let's see, if I pull out the 1/2, I'm going to pull this 1/2 out. So that's going to be 9 divided by 250, and then let's integrate this. So that's going to be theta minus 1/2 sine 2 theta, and we're evaluating from pi divided by 2 to 0. So let's plug all that in. You're going to get 9 divided by 250 times, plug in pi over 2, minus, when you plug in pi over 2 here, the 2's will cancel. So sine of pi is 0. So that's just going to be minus 0. And then when you plug in 0, you're still going to get 0. So your final answer is going to be 9 pi divided by 500. And that's it. Thank you. Have a nice day. Bye-bye.